Hello everyone, my name is Rajat Tirpude. I'm delivered to seminar on my topic is nitrations. Let's see what are topics to cover in nitrations. Introductions, application of nitrations, nitrating agents, aromatic nitration and mechanism, theory of aromatic substitutions, kinetics of aromatic nitration, process equipments for nitrations. Nitrations. Nitration is a chemical process. Introductions of nitro groups to into organic chemical compounds to form a nitro compounds is called as the nitration reactions. Introductions one or more NO2 groups into reactions molecule form a nitrations. In a nitrations, NO2 groups become attached to carbons to form a nitro aromatics. NO2 groups attached to oxygen to form a nitroesters. NO2 groups attached to nitrogen to form a nitroamides. In nitration reactions, a monovalent replace a monovalent group of atom or group of atoms and replace a hydrogen atom or group other than the hydrogen atom. The following the example. This is alkyl halide reacts with silver nitrate to form or two compounds, nitroesters and nitro compounds. Another example is a sulfuric acid reacts with excess of nitric acid to form a these NO2 groups and attack on the ortho positions. These NO2 groups attack on the ortho positions. Then again add a nitric acid to form this NO2 attack on para positions to form a trinitrophenols. Then applications of nitrations. Nitration reactions are very useful and important in pharmaceutical industry, such as solvent, dyestuff, pharmaceutical industry, exports such as bombs. Nitroaliphatics are used as a solvent and synthones in organic synthesis. Nitroaromatic compound used as a plastics synthesis of a plastics. Nitrating agents, various types of a nitrating agent used in nitration reactions. Fuming. Fuming means fine suspension of a particles can seen like gas, concentrated and aqueous nitric acid, mixtures of a nitric acid with sulfuric acid, chloroform, acetic anhydride, acetic acid, phosphoric acid, nitrogen pentoxide, nitrogen tetroxide, nitrile ions means NO2 plus. The mixtures of a two strong acid, nitric acid and sulfuric acid. Nitric acid is existing in a strong sulfuric acid to form a nitrile ions. See these reactions. In these reactions, nitric acid reacts with the sulfuric acid to form a nitrile ions and hydronium ions. Vento factor number of particles generated by the 1 moles of a solid. Vento factor it means ratio between the actual concentration of a particles. Um, the number of particles which this is the number of particles nitrating agents, ethyl nitroesters, nitrogen pentoxide, nitrogen tetroxide. This number of particles by 1 moles of a solute reacts with sulfuric acids to form a nitrile ions to form a nitrile ions to form a nitrile ions form a concentrations of a particle. Okay, aromatic nitrations. In an aromatic nitrations benzene ring reacts with the nitric acid to form nitrobenzenes. In that, nitrile ions is an electrophilic reactant. Electrophilic is plus charge. Electron deficiency. The, the electrophiles attack on the electron rich. Okay. In aromatic nitrations, suppose a benzene ring. Hmm. Suppose a benzene ring contains 6 carbon atom. This carbon are a strong electron density. Okay, the strong electron density and two groups attack on ortho meta para positions. The product is depends on the substitutions. Okay, when a certain substances cause the electron density to be greater at ortho and para positions than meta positions, the yield of a nitrations of a product and in which ortho and para has predominated. Greater electron density of other substituents at meta rather than ortho and para positions, hence they are called meta directives. The certain substances attack on ortho and para positions because electron density, a greater electron density of that, and maximum product form in para positions. Okay. A certain substances and other substituents attack on meta positions. The meta directing groups meta product will form. This is called as a meta directions. Meta directing. Aromatic nitrations mechanism. Combinations of a nitric acid and sulfuric acid produce a nitronium ions, a powerful electrophiles. The reactions with the benzene to produce a nitrobenzene. There are two steps of a reactions mechanism. In first step, formations of electrophiles. When nitric acid and sulfuric acid reacts, the hydrogen atom oxygen contain two lone pairs of electron. Hydrogen atom attack on the oxygen lone pair of protons, produce a water molecules, and these water molecules are break with nitronium ions to form a nitronium ions. In second step, loss of a protons. Benzene ring is a nucleophiles. Nucleophiles an attack electrophiles of a nitronium ions. The intermediates form electrophilic nucleophilic intermediates. Cationic intermediates draw resonance structure. Okay. These double bonds are to break the adjacent hydrogen atom is here, and the water molecules to attack on this hydrogen atom to produce a hydronium ions, and this these electrophiles and nitronium ions attack on one, and resonance will start. Resonance structures will start formations of nitrobenzenes. Naphthalene series is also part of aromatic nitrations. In a naphthalene series, two different mono nitro derivatives. First is alpha, and then second is a beta. Series reaction. This is a naphthalene series reacts with the nitronium ions. Nitric acid. Okay. These NO2 groups attack on a first positions. The product will form a 1 nitronaphthalene and 2 nitronaphthalene. Is this compound is alpha, and again we add or nitric acid, the NO2 compounds attach on fifth and eighth positions. The product will form a beta compounds will form. Theory of aromatic substitutions. In that, two effects are most important: inductive effects and mesomeric effect. Mesomeric effect, also known as the resonance effect. First of all, we see the inductive effects. What is the inductive effect? Inductive effect, displacement of sigma sigma electrons. Two types of inductive effect: plus inductive effect, negative inductive effect. Okay. Okay. Carbon chloride is a sigma bond. These sigma bonds, hmm, this sigma bonds are close to the chloride. Chloride is a more electronegative atom. They develop more electronegative atom. That's why they develop a partial positive in carbon and partial negative in chloride, leads to polarizations. A positive inductive effect, carbon shows a positive inductive effect. This chloride has a pulling the electrons from the effects. Chloride pulling the electrons from the effect. And a negative inductive effect means this chloride attack towards its effects. That's why it shows the negative effects. Okay. Positive inductive effects and negative inductive effects. Positive, substitutions and repel the electrons and are causing all the positions in the ring to be more reactive than in substitutions benzene. Negative inductive effects, substitutions attack the electrons causing all the positions in the rings and are to be less reactive than benzene. Okay. In a positive inductive effects, ortho and para positions are most effective than meta, and negative inductive effects, meta positions are most effective. In positive inductive effects, ortho and para directings will make. Negative inductive effect, meta directings. The order of a decreasing strength are alkyls. The order of a decreasing strength in negative inductive effects, halogens and nitro. Resonance effect. Resonance effect, it shows in benzene ring, all the aromatic ring. It's also two types, positive and negative. Okay. The substitutions is form electron donating groups. The electron donating groups is alcohol, OR, SH, AR, NH2, NR2. And negative resonance effect, the substitutions is an electron withdrawing groups. Electron withdrawing groups are two double bonds, carboxylic, carbonyl compounds, carboxylic acid, sulfonic. Okay. All the positions. Positive resonance effect active all the positions, negative resonance effect deactive all the positions. Positive resonance effect ortho and para directing making compounds, negative resonance effect meta directing compounds. And positive effects example OH, OR, SH, SR, NH2R. For example, alcohol and NH2 groups withdraw electrons by inductive effect, negative inductive effect shows. However, they also release the electron by delocalizations of a lone pair, positive resonance, since the resonance effect is more stronger than the inductive effects. Result is the electron releasing and to rest of the molecules, and this is clearly observed in phenols and aniline. High are more reactive than benzene toward the electrophilic substitution reactions, whereas the inductive effect is stronger than the resonance effect in case of a halogen atom, and others are electronegatives and hence exist negative inductive effects. However, at the same time, they also release electron by delocalizations and positive inductive effects of a lone pairs. Let's see the resonance effect. It shows OH. It's phenol. A phenol contain oxygen contain two lone pairs of electron. Okay. It shows the resonance effect. These lone pairs of electron it attack on this carbon and formations of a double bond. Okay. This oxygen has a plus charge and this bond will break to attack on this. The negative charge will occur. This negative charge it shows the electron density of the carbon it's high and the electron density of the oxygen it's low. This OH has a lone pair and shows a positive resonance effect because electron donating groups. Resonance inductive effect is stronger than the resonance effect in the halogen in case of a halogen atom. Yes, because halogen atom it's contain negative charge and they shows electron withdrawing groups. That's why he shows a negative resonance effect. Kinetics of aromatic nitrations. Kinetics of a nitration reaction is it depends on a reaction nature. Nitrations in mixed acid, nitric acid and sulfuric acid. Compounds are nitrated conveniently measurables and a rate in this system are these which have strong negative inductive effects and negative resonance effects such as the nitrobenzenes and ethyl benzoates. The rate of nitration proportional to the concentrations of adding nitric acid and organic substance. Okay, when a mixtures of nitric acid and sulfuric acid, it strong negative inductive effects and resonance effect it shows such as in nitrobenzenes. The rate of nitrations is increases to concentrations of nitric acid. When we increase in a concentration of a nitric acid, the rate of nitration product also increases. Okay, nitrations in an organic solvent. Which solvent? The mixtures of a nitromethane or acetic acid with a nitric acid. Okay, when we take acetic acid with a nitric acid in nitrations, okay, the kinetics of the process depends upon aromatic compounds bearing nitrate. Okay. The strong reactive groups are nitrate at the rate which proportional to the concentration of a substrate. Compound which are more reactive than benzene such as toluene reacts at the rate which independence of a substrate. Yes, because acetic acid it's contain carbonyl compounds. The mixtures of acetic acid and a nitric acid it's strong reactive groups because acetic acid is a carbonyl compound is electron withdrawing groups. Okay, it shows negative resonance effect at the rate and which proportional to the concentration of a substrate. That's why it's a more reactive than benzene, such as a toluene reacts at the rate which is independent of a substrate. Nitrations in aqueous nitric acid. Aqueous nitric acid is a highly reactive substance. It shows zero order kinetics, and less reactive compound shows first order kinetics. Effects of a nitrous acid on nitrations. A nitrous acid causes inhibiting effects in the nitrations of a compound having no activating groups. Thus, the reaction should carry out in a strong acid and or mixed acid. Nitrous acid causes a catalytic effect in the nitrations of a compound having a reactive group and thus can be nitrate in a weak nitric acid. This nitric acid effects in the nitration reactions too, because the nitric acid has a no activating groups. That's why we mostly used in a strong acids which mixture sulfuric acid and nitric acid mixture are used in nitration. Nitrous acid why not use? Because it causes an catalytic effect. Nitration of a compound having a reactive groups and can be nitrate and a weak nitric acid. Oxynitrations. Oxynitration reaction occurs between the benzene and 50% nitric acid contain 0.2 mole mercury nitrate. The yield up to 85% dinitrophenol and picric acid. Gas phase reactions. Paraffin compounds are quite two nitrate agents. Paraffin can be attacked by a certain atom and free radicals. It's free radical reactions. Nitration of this compound is carried out commercially in a vapor phase at temperatures 350-450. Nitric acid of 70% strength is less is generally used. Variety of a product are formed. For example, nitrations of a 2-methylpentane, which yield nitromethane, nitroethane, 2-nitropropane, 2-nitrobutane, 1-nitroisobutane, 1-nitro-3-methylbutane, 2-nitro-3-methylbutane. The reaction is carried out by passing the reactant and through the reactions chamber in flow. The system's product are considered and distilled. There is optimum temperatures and a highest yield is obtained. Oxygen, the yield of a nitromethanes, nitroethane and nitrobenzene. Increase in additions of oxygens will lower the optimum temperatures and decrease the conversion yield. In gas phase reactions are paraffin compounds to used in a nitrating agent. Paraffin used as a nitrating agent. Paraffin attack on the free radicals. Nitrations, paraffin at a vapor phase at temperatures and 350 and 450. The strength is a less. Nitric acid of a strength is less than 70%. In nitrations, various types of a product will form. If increase in additions of oxygens and the optimum temperatures and improve decrease in the conversions of a yield. Nitrogen dioxide and reacts with the paraffin yield to yield nitrofaraffins at 350. Okay. When nitrogen dioxide is reacts with the paraffin, increase at temperature 350 to product will form and nitroparaffins. More product will form and nitroparaffins. A bromine has a also beneficial effect to yield on a yield and conversions to nitroparaffins. Liquid phase nitrations liquid phase nitration is a less important, less yield, low conversions, replacement of a hydrogen by nitro groups. No reaction possible involves and replacements of a alkyl group by nitro group. Process equipments for technical nitrations. There are two types of equipments are used in a nitrations. First is a batch nitration, then and second is a continuous nitration. What is a batch nitration? A stainless steel vapor or closed cast irons to use in to used nitration. Modern practices are to use carbon steel. It consists of a cylindrical vessels, contains some kinds of a cooling surface, agitations, feed inlet, and product outlet. Okay. They are also equipped with a large diameter, quick dumping lines for emergency if the reaction get out of control. The content of a nitrating are dumped rapidly into the large volume of water confined in a drawing tube. Cooling is generally accomplished by coil of a tube through either cold water. Control of temperatures in a nitration's wall jacket is usually not sufficient enough. Expect in the case of vessels of a very small capacity. Advantage of a coils: high coolant. Disadvantage of a coils: cleaning is no easily and a filling and scaling. Continuous nitration: continuous process carry out sometimes of vessels used for batch nitration is the same as a batch nitration vessels. Means in an batch nitrations are a stainless steel vessels and mm, and cast irons, closed cast irons used in a nitration, and carbon steels and cylindrical vessels contain and in then cylindrical vessels and kinds of cooling surface agitators and feed inlet, feed outlet, and product outlets, and a large offer diameters and a dumping of lines, and when product it forms, and it's a high volume and a large volume of water and drawing tubes, and auto it's a cooling air generally accomplished by the coils and their cold water. This it's also in continuous nitration process. The exception that an overflow pipe or wire where arrangement is provided for the continuous withdrawals of a product and that the continuous feed of a reactants is provided. Automation is a continuous process. Continuous nitration is the automation of a continuous process. It's provide for its overflow of a pipes, exceptions of overflow of a pipes, and is continuously withdraw of a product. The continuous and continuously feed of a reactant it provides. This is a stainless steel tank. Another in this stainless steel tank and a continuous feed of a pipe and overflow of a pipe and exceptions of a if a product will overflow that's pipe and exceptions there are exceptions. It automation process. Automation is a continuously process. Thank you.